So we are going to solve problem 3.27 from Sadiku. So our task is find node voltages V1, V2 and V3, and I will make this as our ground. And if we pay attention here, the unit of the resistor is not in ohm but in Siemens. Siemens is the inverse of the resistance, so 1 Siemens is 1 over ohm. So I think we need to change what we view about the circuit. If we usually use ohm law, we know that I is equal to V divided by R, but this is not the case here because our R here is the inverse. This is conductance, so let's call that G. So G is equal to 1 over R. So if we substitute this here, so this can be written as 1 over R times V. So we will have I is equal to GV. Okay, let's work by using this formula. So let's save that I is equal to GV here. This is our Ohm's law, and we will start by using that law. I will erase this one. So let's start at not V1. So I will draw my line here. Let's start by using KCL at V1. So we first need to assume where the current is going, and as usual, I usually make the horizontal one goes to the right, the vertical one goes to bottom, and it usually works every time. So we start at node 1. This one more current obviously going there. So the current that goes in is equal to the current that goes out. The only current that goes in is this 2 ampere current source, so 2. And the current that goes out, there is 4 current, 1, 2, 3 and 4. So for this one, I will use V1 divided by this resistance, but this is not resistance but conductance. So we will have 2 V1, not V1 divided by 2, but V1 multiplied by this one, and then plus this is 1 Siemens, so 1, and then we don't need to write 1, so I will erase that. So we V1 minus V2, V1 minus V2, and then plus this direction 3I0, and then for that one plus it's usually V1 minus V3 divided by this resistance, but it's multiplied now, so I will have 4 V1 minus 4 V3, and okay, so we do some algebra here. V1, 2 plus 1 plus 4, it's 7 V1. For V2, we will have only that current, not current, voltage. And for V3, we only have this one, minus 4 V3, but we have plus 3 I0, and we can take a look at I0. I0 is this current, and we can apply Ohm's law also to that I. So I will have this one plus 3 times, I will use this X symbol. V2 is, no, I0 is V2 divided by this resistance, but this is conductance, so I will have 4 V2, and I will have 2 is equal to 7v1 minus v2 minus 4v3, and this one is 12v2, and I will have 2 is equal to 7v1, and this one is plus 11v2 minus 4v3. And let's save these equations as equation number 1. Now we can do KCL at v2. KCL at v2. The current that goes in is equal to the current that goes out. The only current that goes in is here, so I will have 1 times v1 minus v2, and then the current that goes out is this current, so I will have 4v2 plus the current that goes out again, so I will have 1 times v2 minus v3, and we can do some algebra here, and that one is 5v2 minus v3, and we will have v1 minus 6v2 plus v3 will equal to 0. And let's save this as equation number 2. And now we are looking at these notes. KCL at v3, all the current is going in except for this current, so let's do that. So first current is here, and I will have 4 v1 minus v3 plus 3i0, but i0 is 4v2, so I will have 12v2 and then for this one I will have plus 1 v2 minus v3, and the last one is plus 4, and that will equal to the current that goes out, and I will have that as 2 v3. So let's do some algebra here. I will have 4v1 minus 4v3 plus 12v2 plus v2 minus v3 plus 4 is equal to 2v3, and let's simplify this one. So I will have 4 v1 and then for v2 I will have what will I have, plus 12 plus 1 is plus 13 v2, and for v3 I will have minus 4 minus 1, which will become minus 5, and minus 2, so I will have minus 7, and for the last is 4. I move to the right hand side, so it is minus 4. Let's save this equation as equation number 3, and we have these 3 system of equations, 1, 2, and 3. The only things we need to do is solve these equations. So let me write the matrix that we need to solve in MATLAB. So for the first, it is 7, 11, and minus 4, and then the second one it's 1, minus 6, and 1, and the last one is 4, 13 and minus 7. So this one multiplied by matrix V, and it will equal to, for the result we will have this one is 2, and this one is 0, and the last one is minus 4. And let's me erase all things that not needed. You can plug this into MATLAB by naming this matrix as matrix A and this matrix as matrix B. You can just do inverse A multiplied by B and we'll name it matrix V, and let me calculate the result using MATLAB. So I check the result using MATLAB, and for this matrix V I will have V is equal to 0.625, 0.375, and then 1.625. And from this one we can imply that this is for V1, V2, and V3. So V1 is 0.625 volt, or we can write it in millivolt, 625 millivolt. And for V2 we will have 0.375 volt, or we can write it in millivolt like this. And for the last one we will have V3 is 1.625 volt. And this is our final result. Let me know if you find any mistakes in my calculations. Thank you.